wanted to talk a little bit more about 10.3. Continued again. So what I want to focus on right now is what we call a normal distribution. And to do a normal distribution, we use what we call the bell curve. So a bell curve literally looks like a bell. It should be more symmetrical, but you know. All right. And the way a bell curve works is your mean is directly in the middle. This is the mean. Get my little dash out of here. Then each side of the bell curve is split into a certain percentage. Okay? So the first or the biggest group is split with 34% on either side of the mean. So that means 68% is all in the center, right around all the data. The next section, broken off, is this percent is 13.5. And we have the same percent on this side. It is 13.5. Then we have one more little section on each side. This section right here is 2.35% of the data, and the same on this side, 2.35% of the data. And you'll see we have these other little tails right at the very end. On each side, that's only 0.15%. So if you were to add all those percents up, it comes back to 100%. So when we're talking about the bell curve, this is our 68 is in the center. Then the next section, including that 68 in the middle, is 95% total. Then the next section, including all of that data, should include 99.7% of the data. This last little bit on either side, that 0.3, is any outliers they sit out there, the rare occasions. So, for example, if we were taking a test and the average test score was a 75, right, then 68% of the data would be around 75. 68% of the test scores. Over here would be the lowest score, and over here would be the highest score. That's how it should sit. If you have a perfectly designed test, that's what it should look like, is most of the people score right in the middle. All right? This is the standard bell curve. Now, each one of these segments is called a standard deviation. So if you were to hear you are 2 standard deviations ahead of the mean or above the mean, you would be in this part right here. If you were a standard deviation below the mean, you would be over here. Fits on that line. Okay? Now we're going to be calculating some standard deviations. Standard deviation falls in 2 categories. So sometimes the symbol we use is S, with a little line over it. And sometimes we use a little theta mark. Either one is going to be our standard deviation. So if you go in, and we'll talk about the difference in a second. So if you grab your calculator, go back into like the last statistics you put in, right, where you had a 5-number summary. Towards the top, you'll notice some other symbols underneath the mean, which we said was X with a line over it. Do you see the two symbols that look similar to this?
Wait, where do we go? Stat and then...
Mm-hmm.
Oh, like that.
So that's going to tell you your standard deviation. One is a sample of the population. The other means that it's the entire population. Mm-hmm. Yes, that's correct. Okay? So we're going to be finding where certain things fall. And next week, once we're all together, we're going to be calculating our percentile when you get a certain score or where you fit within a certain mean. So for example, they say the average woman is about 5 feet 5 inches tall, right? That's average. So I would be above average. But where in the standard deviations would I fall, right? Or there's some young ladies in the school that would be below average, right? Where do they fall? So we're going to be able to calculate all that, and that's part of statistics and part of where you fall on this beautiful bell curve. Yeah, we're going to be talking percentiles. Inside this, we're going to add another vocabulary word in here. Okay? So we have each of these are a standard deviation. Inside the standard deviation is what we call a z-score. So if you're like fall in here, you can even be more precise by getting a z-score. So if you recall getting your SAT stuff, you had, yeah, I know some of you haven't gotten it yet, but there are z-scores in there to give you even more of a detail of where you fall in the statistics. Okay? So we're going to be going through all of this next week and breaking it down. So we're going to do a lot of calculator work. Yeah, there's a couple different ones. Yes. Yep. We're going to be doing some different things and calculating that stuff. All right? So, I do not feel comfortable enough giving you any homework yet, but what I'd like to do is just kind of go to the first example of what we might do. So example number 1. So if I were to tell you that the mean score on my test, mean test score, is a 78, okay? And it has a standard deviation, and I'll use this symbol this time, a standard deviation of 2.5. I want to show you exactly what that means. So on my bell curve, first of all, my mean is exactly here in the middle at 78. Now, when I have a standard deviation, to the right, we are going to add 2.5 to 78. So in between here, it has a score, goes up to 80.5. If I go below the mean one standard deviation, then I would subtract 2.5, and so I'd have 75.5. So 68% of the scores should fall between 75.5 and 80.5. Okay? If I go out another standard deviation, I would add another 2.5. So this would be an 83. If I went this direction, I would subtract another 2.5. So this would be 73. So that would mean that I have exactly 95% of the scores are between a 73 and an 83. Okay? Now, if my standard deviation was greater, then there would be a bigger score gap in between the two sides, right? Okay? Let's put one more standard deviation in here. So if I add another 2.5, I get 85.5. And on this side, if I subtract 2.5, I would get 70.5. So this is saying that with only a standard deviation of 2.5, 99.7% of my scores were between a 70 and an 85. Now that's not typically what happens, right? Usually we're a little more higher, right? And we always have some scores that are right at the top. So our standard deviation is probably greater here. You know, especially if we had a couple hundreds and we had a couple 40s. Then it would be way spread out and our standard deviations would be greater. Okay? So the next week we're going to take this and start finding our z-scores where we fit in. All right? Any questions? No? Okay. So, today we're not going to do any homework for the weekend. I want you to enjoy your weekend. We are going to get into this in detail, and I do plan on having a test over Chapter 10 on May 16th. May 16th.